Hello everyone. In this video, I am going to explain more examples of subset construction to convert NFA to DFA. Suppose I have this example where NFA is given and we have to convert it to equivalent deterministic finite automata. Let me start with this table construction. Start from, there are two symbols in the alphabet set. So make these two columns here. Start from Q0. See the diagram. Q0 is the initial state. Q0 on reading 0, it is going on state Q1. Q0 on reading 1, it is not having any transition on symbol 1, so 5. Similarly, Q1 on reading 0, Q1 on reading 0, it doesn't have any, it has. So it is going on state Q2. Q1 on reading 1, it is going on 5. Similarly, now we have two new states Q2 and 5. Take Q2. Q2 on reading 0 is going on Q2. Q2 on reading 1 is going on Q2 only. Now 5 on reading 0 or 1, it is going on the same state 5. What we need to do, we have to make the states for each of these values, that is Q0, Q1, Q2 and 5. So for DFA, we have the initial state of NFA becomes the initial state of DFA. We have already discussed this in the earlier video. This is Q0. See the table, just keep mapping. Q0 on reading 0, it is going on state Q1. Q0 on reading 1, it is going on state, name it 5. Come to state Q1. Q1 on reading 0, it is going to state Q2. And Q2 was the final state, that is accepting state is in the original diagram. So make this as the final state in the DFA. Again Q1 on reading 1, it is going on state 5. Now Q2 on reading 0 is going on Q2. Q2 on reading 1 is also going on Q2. 5 on reading 0 or 1 is going to 5. So now this is the DFA. This was the non-deterministic finite automata. The equivalent deterministic finite automata for the given diagram is this. Now let me take the next example. In this case, there are two symbols A and B. Make the column for both the symbols. Start from the initial state of NFA. Initial state of NFA is Q0. Q0 on reading A is going to state Q0 as well as Q1. This is B here. And Q0 on reading B is going on state Q1. Come to Q1. Q1 on reading A. Q1 on reading A is going to state 5 because Q1 doesn't have any transition on A. Q1 on reading B is going to state Q1. Now there are two new states Q0, Q1 and 5. So explore these two elements Q0, Q1 on A and Q0, Q1 on B. So what was the method of doing this? Delta Q0, Q1 on reading A is delta Q0 A union delta Q1 A. See the original diagram, that is this diagram. Q0 on reading A, Q0 on reading A is going to state Q0 and Q1 union with Q1 on reading A is 5, so I get Q0, Q1 only. So I will write this as Q0 Q1. Now repeat the process for symbol B. Q0 Q1 on reading B. So delta Q0 with B union delta Q1 with B. Q0 on reading B is going to state Q1 union delta Q1B, that is transition of Q1 on reading B is Q1 only. Q1. I get Q1 here. So we do not get any new state here. We'll just explore phi. Phi on reading A is giving us phi, and on reading B also phi. Now I'll make the diagram for DFA. Start with Q0. Q0 is the final state in the main diagram, so I'll make Q0 as the final state here also. Subset form. And then again see the diagram table. Q0 on reading A, it's going on state Q0 Q1. Q0 on reading A is going to state Q0 Q1. Now see, since Q0 was the final state in the main diagram and Q0 element is there in this subset, so I'll make this as an accepting state. In the earlier diagram, Q1 also was the accepting, that is both Q0, Q1 are the accepting state in the previous initial diagram, NFA diagram. So I have to make it a final state whenever we have even a single element, at least one element is in the subset is the accepting state in the main diagram, that is NFA diagram, then we have to make it as the final state or accepting state. Now see Q0 Q1, Q0 on reading B is going to the state Q1, and since Q1 is an accepting state in the main diagram, so it has to be an accepting state here also. Now we have these three states. Also we have Q0, start with this Q0 Q1 on reading A is going to state Q0 Q1. Q0 Q1 on reading B is going on state Q1. Q0 Q1 has both the transitions completed. Now come to Q1. Q1 on reading A, it is going on state phi. Phi on reading 0 or A or B stays there only. So these two transitions. Phi on reading A is on phi. Phi on reading B is also on phi. So I hope I have completed all the transitions. No, Q1 on reading B stays on Q1. Q1 on reading B stays on Q1. Now this DFA is completed. NFA and equivalent DFA. Remember one more point. Whenever we convert NFA to DFA, we might get some redundant states. For which we have an algorithm that converts DFA to minimal DFA. Minimal DFA means we have removed all the redundant states from the DFA. In this diagram, we have some states which are like equivalent to one another. They can be merged with by following some algorithm. That algorithm I'll be discussing in the next video, where we convert the DFA with the redundant states to minimal DFA. That is, we will remove the redundant state in that. So for that, so we'll be following some algorithm which we will discuss later. Now we'll see the next question. convert this NFA to DFA. How to do that? Start from the initial state. What is the initial state in the main diagram? The Q naught is the initial state. What are the symbols? Sigma here is 0, 1. So there are two columns, one for 0, one for 1, and start from Q naught, that is the initial state. Q naught on reading 0, Q naught on reading 0 is going on the state phi. We do not have any transition for 0 in the NFA. Similarly, Q naught on reading 1, it is going to two different states, Q1 and Q4 as well as Q2. There are three states where it is going by reading 1. So Q naught on reading 1 is going to Q1, Q4 and Q2. Q1, Q4 and Q2. Q1 on reading, Q naught on reading 0 was not having any transition, so we have given phi. Q1 on reading 1, it has three directions. We can clearly see on reading 1 it is going to Q1 as well as Q4 as well as Q2. So the subset is Q1, Q4, Q2. Now there are two elements. We'll explore both the elements one at a time. Q1, Q4, Q2. On reading 0 and on reading 1, we have to write it in this way. Q1, Q4, Q2 on reading 0, that is delta Q1 0 union delta Q4 0 union delta Q2 0. See the diagram. Q1 on reading 0 is giving us phi, union with Q4 on reading 0 is giving us phi, union with Q2 with 0 is giving us phi. So what I get phi here. So I will write phi. Repeat the process for the symbol 1. Q1 on reading 1, Q4 on reading 1 and Q2 on reading 1. We'll see the diagram and we'll find out this. Q1 on reading 1 is going on Q naught. Q4 on reading 1 is giving us phi as there is no transition of 1 on Q4. Similarly, Q2 on reading 1 is going to state Q3. So we have Q naught, Q3. Q naught, Q3. Now take this Q. This is the new element that has been generated by exploring this. So therefore I will take this Q naught, Q3 here. I'll repeat the process for Q naught, Q3 on 0 and on 1. Delta Q naught on reading 0 union delta Q3 on reading 0. Q naught on reading 0, it is giving us phi, union with Q3 on reading 0, it is giving us Q naught. So I'll write this as Q naught. Repeat the process for symbol 1. So Q naught on reading 1. Q naught on reading 1 is giving us Q1, Q4, Q2 and Q naught Q3 on reading 1. Q3 on reading 1 is giving us phi. So this is Q1, Q4, Q2. We can clearly see when we explore Q0, Q3 for symbol 0 and 1, we are getting the states Q1, Q0 and Q1, Q4, Q2, which we have already explored earlier. In the earlier rows, we can see that Q0 is already been seen for both the symbols. Q1, Q4, Q2 is already seen for the symbol 0 and 1. We just have to put the value for phi. We know that phi on reading 0 is phi, phi on reading 1 is phi. So now we have the table is completed. We just have to make the diagram for this table. Start from the initial state, that is Q0. Q0 on reading 0. On reading 0, it is going to some state phi. Phi on reading 0 or 1 stays there, phi only. Just copy the table into the diagram. Now Q0 on reading 1, it is going to some state. We call it Q1, Q4, Q2. Also check if Q1, Q4, Q2, any of these values, any of this value, if it is a final state in the main diagram, I'll make this as the final state. Yes, since Q4 is the final state, that is accepting state in the NFA, so and Q4 is present in this subset, so I'll make this state as the final state. Now see the transition of Q1, Q4, Q2 on 0. On reading 0, it is going to phi state. On reading 1, it is going to some state Q0 and Q3. Q0, Q3. Q0, Q3, I will not make this as the final state in this diagram because neither Q0 nor Q3 are the final state in the main diagram. So therefore, this is just a normal state. Q0, Q3 on reading 0 is going to state Q0. Q0, Q3 on reading 0 is going to state Q0, and Q0, Q3 on reading 1 is going to state Q1, Q4, Q2. So I think we have completed the transitions. All the transitions are completed for all these states, and I hope this diagram is clear to all of you and you know how to convert NFA to DFA using subset construction. Please do let me know in the comment box if the concept is clear, and also give some of your doubts or queries. Anything you have to say, please write in the comment. Thank you so much for watching the video.